Okay, let's unpack this. Have you ever wondered how a massive sports bar seamlessly controls dozens of TVs? Or, how an HD webcam works flawlessly when the computer it connects to is like hundreds of feet away?
Yeah, it's something you don't really think about until you have to set one up yourself.
Exactly. So today, our mission for this deep dive is to uncover the hidden technological infrastructure making these massive commercial AV setups and long-distance digital connections possible. We're pulling from tech specs and product catalogs from HDTV Supply to figure out the invisible magic happening right behind the drywall.
And I mean, that magic is largely about tricking data into traveling further than it physically wants to, right?
Mhm.
Because native USB cables, they degrade rapidly.
Right, like a short garden hose.
Yeah, great analogy. Try to stretch that hose too far, or push a high bandwidth signal past a few meters, and the voltage drops, the latency spikes, and, well, the connection ultimately just fails.
Which brings us to a brilliant workaround we found in the specs for the Intelix DIGI-USB2-4P system. Instead of fighting the USB cable's physical limits, this system basically abandons the native cable entirely.
It does. What's fascinating here is the mechanics of that conversion. A standard USB cable sends raw voltage that is highly susceptible to decay over distance.
Because it's just not built for the long haul.
Right. But Cat5 or Cat6 networking cables use tightly wound pairs of copper wires, and that twisting physically cancels out electromagnetic interference. So the Intelix system actively translates the USB signal into a format optimized for those twisted pairs.
So you're basically taking a fragile signal, locking it in an armored car, and driving it down a dedicated highway.
Exactly. It shoots it down the line and translates it back at the destination.
And by doing that, you can push a high-speed 480 megabit per second connection up to 330 feet. That's 100 meters with zero data loss.
Which is huge for you if you're deploying, say, an interactive whiteboard in a massive lecture hall, or maybe a remote security camera.
Yeah, and it's strictly plug and play too. No software drivers to install. The receiver end even acts as a 4-port hub, so you can power multiple devices remotely off that single run.
But, solving that point-to-point distance problem is really just the foundational step, because when you walk into a massive venue, you aren't just looking at one extended webcam.
No, you're looking at a chaotic web of overlapping high-definition video feeds.
Right. Sending one signal 300 feet is one thing, but managing dozens of distinct video signals without the entire system buckling is a whole different beast.
And this is where I actually initially misunderstood the hardware. I assumed venues just used like heavy-duty HDMI splitters.
A lot of people do.
But the HDTV supply catalogs point to something much more complex. The Wolfpack fixed HDMI matrix switcher.
Yeah, because a splitter is really just a brute force tool. It takes one cable box and clones that exact same image to every single screen in the building.
Whereas a matrix switcher operates more like a dedicated digital traffic controller.
Exactly. The 16 by 16 Wolfpack model, for instance, uses an internal microprocessor to route 16 independent sources to 16 different TVs simultaneously.
So any screen can show any source at any time, totally independent of the others.
Right.
Okay, but here's where it gets really interesting, though. I'm looking at this 16 by 16 fixed switcher, and honestly, it seems like a trap.
How so?
Well, in tech, you generally want modularity so you can upgrade later. Why would a business intentionally lock themselves into a fixed chassis with a hard limit of 16 inputs and outputs, rather than buying a modular system where they can swap in new cards down the road?
It really comes down to architectural certainty versus speculative overhead. A fixed matrix is built on a single integrated circuit board inside one chassis.
So it's simpler.
Much simpler. Because the manufacturer doesn't have to build complex internal bridging for swappable modular cards, the fixed unit is significantly cheaper and infinitely easier to deploy out of the box.
Oh, I see. So if a sports bar has exactly 16 displays and the walls are already sealed, their needs are static.
Exactly. Buying a modular frame for someday is just paying for empty hardware slots you'll probably never use.
Makes sense. So what does this all mean for you? The next time you sit in a sports bar or a high-tech conference room, you'll know there's a complex, invisible nervous system at work.
Yeah, right behind the drywall, you've got matrix switchers acting as the brain and miles of Cat6 extenders acting as the nerves, keeping all that data flowing perfectly.
And this raises an important question to leave you with. The source material highlights massive physical infrastructure here. We're talking 450-foot Cat6 cable runs and heavy 80 by 80 matrix chassis to handle these commercial networks.
Right.
As consumer tech constantly pushes us toward a wireless world, will these commercial high-bandwidth systems ever truly cut the cord? Or is the illusion of our wireless future permanently tethered to hidden physical cables?